I thought I'd take a quick recap of what our goals were for MEF, why we did it, and a little bit about what we've heard from the community that's been using it, what they liked, what they didn't like. And then what I really want to do with this talk is explore some real-world implementations that have been using MEF and how they've been using MEF. So this is not going to be so much of a, here's all the cool things you can do with the technology in terms of, here you can call this thing or call this method on the API. It's more going to be, here's different patterns of how you can use MEF within your applications and different problems, and I'm going to use real-world apps as an example. And because MEF was under open source as well, that meant that the open source community really took hold of MEF. There's a ton of open source projects that were using MEF well before it shipped. One of them was MEF Contrib. And MEF Contrib had like a personal mission to say, yeah, MEF's not an IOC in V1, but we're going to provide the pieces to make it work like an IOC. And we actually, what was great about that is Andreas Hackinson, who's the lead of MEF Contrib, who now doesn't care as much about MEF Contrib because he started this new project, Nancy, that's been taking off like wildfire. Anybody here heard of Nancy? Nancy's like a web framework similar to Sinatra on Ruby. And it's trying to bring the Sinatra experience to .NET. And you have to squint. It does some interesting things with lambdas and other stuff to get you that Ruby-esque Sinatra-type syntax, but some people just absolutely love it. But anyway, when we were developing MEF V1, Andreas and I were pairing up in the evenings trying to come up with, like, stress MEF to make sure that in the future it could do all the things that people said it couldn't do. And almost everything people said it couldn't do, I proved it could do. Whether or not we had the bandwidth to do it was a different story. The biggest kind of things we heard were, we want to be able to do AOP. AOP was the huge one. We want to be able to do interception. Well, guess what? If you get MEF Contrib right now, you can plug in whatever AOP framework you want. So MEF supports it, the design supports it. It's just not been an area that was our key focus in V1. So we did a lot of work in V1 to enable things that either we would want to do in V2 or the community. And working with Andreas was great because he practically rewrote MEF on his own in the early days. And we looked at what he did and saw all these gaps and said, okay, let's at least make it easier for the person who wants to come, extend it, and do these things that we're not focused on in V1, be able to do it. So anyway, Andreas is awesome. He actually got an award from Soma when we shipped, because he really was like the third, you know, the extended member of the MEF team, even though we weren't paying him. So, why we did MEF? That's a diagram of a lot of monolithic blocks. And in MEF, our whole goal was to move you away from that towards this. Right? Legos are really malleable and pluggable. You know, I love when Hanselman's doing his talk on Legos, because I've been doing talks on Legos forever, not necessarily from a NuGet perspective, but from the idea of applications that can be assembled very easily and functionality can easily be swapped in, swapped out. And in this case, it's not so much about cross-cutting concerns. A lot of the kind of things with NuGet are more layering, like I've got my data access technology or my ORM technology or this monitoring technology, etc. Whereas this model is more like, imagine an application that functionally does A, B, C, D, E, and those pieces all just come together. The closest thing that I would say is moving on this path is Orchard. If you look at ASP.NET Orchard, it really takes this idea of an application being assembled through building blocks. So that's what we wanted. And the reason we wanted that was selfish. We were suffering big time within Visual Studio, within other parts of our company. And those parts of the company have all soaked up MEF, like they just can't get enough of it because that was such a pain for us. We're such a big company, all these different teams that are working together and having really tough problems of how to put stuff together. So that's really what MEF is designed to do. It's to break things up, but break it up into pieces that can then be molded back together very easily and snapped. And we wanted to get you from this type of state where you're going out of your mind to this nice, calm, relaxing state, right? I love what Hanselman talks about, developer joy. I think that was one of the goals with MEF. Make it easy to do the stuff you want to do and not have to suffer with a lot of pain. But it's also joy for your customer. That's the place where MEF really gets interesting. It's not just about you and your application. It's about your customer looking at the app and saying, you know, it would be really great if it did this. Guess what? I can do it. That's joy. So MEF equals joy. I used to do this slide at one of my talks, which was MEF makes extensibility fun. You know, MEF, haha. I think one of the powers of MEF is its simplicity. At the end of the day, there's only a couple of concepts you have to know to grok MEF. The first concept, or the first, I would say, tenet is you have to accept the fact that although building monolithic apps may be cool, it's not going to be the friendliest experience. If you want to be able to move forward, you need to move away from that monolithic style application and accept the fact that things need to be partitioned and more modular. MEF is all about modularity. And it allows you to break things up at whatever level you want to. So when I was on the Prism team, we had a concept called modularity that we use, and it's a concept that's existing. We didn't make that concept up. Well, maybe we did. We put like a TM. That's the Microsoft version of modularity. Modularity TM. But in Prism, modularity was very granular. These big, large portions of the system. In MEF, it can be as fine-grained or as granular as you want it to be. It could be subsystems. It could be very small pieces. And the way the contracts look is completely up to you. You don't have to spend, I built a lot. One of the reasons I loved MEF is because before I joined Microsoft, I built a lot of extensibility frameworks. Every company I went in, it was just something we ended up doing. We built this, I worked for this company that had a supply chain system. It was a startup, which ran out of money. But before it ran out of money, we were building these nice systems. We were early adopters of .NET, and those systems had these adapters that had to talk to different types of integration systems. This was like pre-BizTalk. And we needed a way to plug them in, and we were writing custom ones all the time. So first thing we defaulted to was an XML file, because that was the in vogue way of doing it, right? Every time the system would load up, it would read this massive XML file. The great thing about XML was you could put all this information in there. The bad thing is if you even mess up one character, you can break the entire thing. So when we were building MEF, we learned from all that. And we said, let's not do that. Let's make that experience better. Let's not have a centralized configuration. So when people would look at IOC, they'd say, oh, with IOC, I love having this one central place. That's the anti-pattern for these types of systems, because you don't want person A, who's adding something to your system, breaking person B. So we really had this idea of make this experience better. And like I said, it's just a couple of essential concepts. You export things. These are the contracts. These are the things I want to make available to the universe. I don't know who's going to get them. I don't care. I know someone might want to get them, so I'm going to make them available. And I import things. But the modularity comes in because I'm not tightly coupled to the things that I'm connecting to. It's only through contracts. I could use concrete types, but what MEF will allow you to do is use interfaces, etc. And the last thing is the composition. That's what assembled that guy. He doesn't look very good. So, like Scott said, you can write bad code, you can write good code, you could use MEF in good ways and bad ways. Ultimately, though, we had this lab where we had this cat. And part of our usability study was we wanted to see if the cat could actually extend MEF. In the early days, a cat used to run away. We couldn't get it to work. By the end, oh my God, that cat was kicking butt. I mean, 2 seconds could get down there and build an application. So we took this photo. It's memorable. No, but seriously, we spent a lot of time continually refining MEF to make it more simple. And we basically made MEF viral. We made it available everywhere. It's available in .NET 4. It's available in Silverlight. It's available in other forms in source, like .NET 3.5. We didn't ship it for .NET 3.5, but we shipped source for .NET 3.5. Somebody even went and ported it to the Pocket PC. That was the advantage of having an open source license. Other people could go and get it. So pretty much everywhere you go, you can find it. You can't find it on the phone in the box yet, though people have ported MEF to the phone. I ported MEF to the phone for Mix last year just to show that it could be done. You don't get all the benefits on the phone because MEF is really about this discoverability where new things can easily get added in, and in the phone you're in kind of a sandbox, so you don't get quite that flexibility. But anyway, it's available all those places. And we learned a bunch of things. So one is a lot of people, when they see MEF, they think it's just about widgets. It's not. It is not a UI framework at all. A lot of people would come to me and say, how is MEF different than Prism? Prism is a UI framework. Prism is about composite UI applications. MEF is just a way to put components together. It happens to work very well for assembling UI pieces as well, but that's orthogonal to what it's for. You can use MEF on the server, you can use MEF on the client, you can use MEF in the back end, you can use MEF in the front end, you can use it wherever you want. It's all about MEF. And you don't have to build your entire system on it. That was another myth. Like, people thought, oh, if I use this, does that mean I have to re-architect it completely? We actually put a lot of effort in to allow you to do things like use property exports. And property exports are a way of saying, here's a component that MEF knows nothing about. There's no way I can attribute it because I don't own the binary. But I can make it available to MEF. And other parts can use it. We also learned some anti-patterns. One of the anti-patterns we saw was people exposing the container. MEF really wants to compose your applications. The more you allow, even though it's a little bit scary, the more you allow MEF to work for you, the better the resulting experience is going to be. And let me give you an example of that. MEF does this thing called rejection. It will proactively look and say, if I'm a part and I need this part over here, if that part's not available, then it will just pretend it doesn't see the part in the first place. Now, that has some positives and some negatives, but the positive side to it is in an application like Visual Studio, where there's hundreds or thousands of third-party extensions coming in, then if one is missing a particular dependency, it doesn't break the application. It may not show up, that little piece, but the rest of the application is completely functional. That is one place that I would say, for example, was very different than the goals of IOC containers. Everybody who's worked with an IOC knows what happens when something's wrong. Blows up. We want it, but that's okay when it's my code. When it's somebody else's code, I don't necessarily want that to happen. We also saw, one of the big anti-patterns we saw where people were exposing the container directly, and it was being queried all over the place. And the downside to that is it prevents MEF from doing some of the proactive things it can do, but it also makes your code more tightly coupled. With MEF, it's all about taking those parts and not just reusing them within an application, reusing them across applications. So I could write a component today in MEF, and I could reuse it in Visual Studio, or I could reuse it in Glimpse, for example, which is an open source product that uses MEF. So, but in order to get that reuse, you really need to minimize dependencies on the host. And anytime you depend on the container, that's a host dependency. The container has to be set up. You might be in an environment where the container was not set up, and that will cause you lots of problems. So what's the alternative? The alternative is to do things through composition. And let me give you an example of a really common case that we had that we addressed in Silverlight through a new type that we created called Export Factory. A common scenario for people that were using MEF in the UI was, I've got some type of UI that for creating orders. Let me give you guys some love. I'm sorry. I'm creating orders, and the user is going to initiate an action, like click a button like new order. And then the order screen itself may be a composition of different components coming from MEF, third-party things, etc. So what people would say is, well, that has to happen not when the app starts up. It has to happen when the button gets hit. So how can I allow that composition to happen without exposing the container? And the way you can do it is you can just create a wrapper service like a factory, that you make available through MEF, but then the code depends on that contract. It doesn't depend on the container, which means it doesn't have that host dependency. And it's very, very easy to do that. Now, in Silverlight, we decided to actually make an investment to make this type of experience better. And we introduced a type, which some of you may have heard of, called export factory of T. Anybody here heard of export factory of T? Okay. What export factory of T is you can say, if I need to create these certain types of views, this I summary view, and I need to create them dynamically on the fly based on a user action, I can take in that export factory of T, and I basically, all I do is put an import. So on a class, for those of you that are not familiar with the MEF syntax, I'll just open Notepad. MEF uses a declarative style. So let's say that I have my orders controller. And that has an export from a MEF perspective. And orders controller, when a user clicks an action, there's going to be a method on here called, say, create order. This is great because I know this can't fail. Create order view, let's say. Actually, we'll pull this back. Okay. What's in there doesn't matter. So what I want to do is, I want this order controller, I want MEF to help this order controller and to give it a factory such that whenever it wants to create one of these views, it can do it. So in MEF in Silverlight, what you can do is you can say, I'm going to take in an export factory of, let's say, I order view. And then what I can do is put an import attribute on it. And now, you'll just have to imagine me clicking the F5 compile, and it just all magically works. I can take that factory and create a view from it. So what will happen is, I'll get what's called an export, which is a wrapper that I can then use to get a value. So I would basically go to the factory and call this create export method. And then off that view export, I would have a value, and that value would be the instance. So what could happen now is, anytime that new order button gets pressed, the code now has the ability to use this factory to create something, another part that gets created on the fly, and MEF composes it, and MEF does everything in a recursive way. So you can have a very deep object graph that gets created dynamically on the fly, and you don't have to go through a lot of pain to do it. Now, in MEF v1, you don't have this in the box, but all I've got to do, because it's all about exports in MEF, is just create my own, public class view factory. That factory inside of it will have a container, but it will shield that away from the calling code, and then the calling code just takes that factory. It's a very simple pattern. Now, fortunately, in MEF 2, we've put export factory in the box for the desktop as well. So it will be there for the desktop. The other thing we learned was about custom attributes. So one of the things that MEF allows you to do is this thing called metadata. Let me show you guys a sample of that. Metadata is a way to declaratively supply additional information about the parts that you're making available. And why that's useful is it allows a consumer to pick and choose from the available set and to see some extra information that it can use to make a decision on if it even wants to use that or not. So you can conserve, Visual Studio uses this heavily because Visual Studio has like 50,000 MEF parts, and if all those things got created at the same time, that would be very bad. So by using metadata, they can literally do like a query and say, find me this subset of information. So let me see if I should have a demo on here. doesn't look like I do. Let me just... Well, I'll just show it to you in Notepad again. Actually, we can just open Visual Studio. It's easy enough. I can show you how easy it is to build a Hello MEF application. Yes, hopefully that worked. So MEF, we'll use Silverlight so I can show you what the export factory is. So in Silverlight, MEF installs as part of the Silverlight toolkit. So it's the SDK. So it's not in the box of MEF that gets installed. Like when you download Silverlight, it's not on the machine automatically. It will download on demand as needed. And that's the way the Silverlight SDK works, so that it can reduce that initial download. So what I'm going to do, and this is going to show you how easy it is to use MEF, is I'm going to go create a Silverlight project, Silverlight application. We'll just call it Hello MEF. Yep. And all of the MEF assembly, all of the MEF components, they live under this namespace called systemcomponentmodel.composition. One of the really nice things we did in Silverlight, too, is make it very simple to get going with MEF, even more so than the desktop. And the way we did that is in Silverlight, you have a zap. You have this package. So in MEF, we will automatically scoop up everything that's in that package rather than forcing you to write a lot of code. So what I'm going to do here is I'm just going to, for simplicity's sake, we'll do it out of the main page, but I'm just going to create a class here. And then we'll see how the export factory works. So I'll call that my orders controller. And now I'm going to have to add my MEF references, which in Silverlight I'll add 2. There's systemcomponentmodel.composition and systemcomponentmodel.composition.initialization. Initialization brings a bunch of functionality like export factory, which we did not ship in the desktop, some of which is coming in MEF 2. Okay, so to make this guy available to MEF, all I've got to do is put an export attribute. And by default, for simplicity's sake, I don't have to add an interface. I might want to. I'm not going to here, just to make it simple. And we'll just put a constructor there so we can get a breakpoint. Yeah. Actually, this should work. Okay. Then in my main page, what I'm going to do is I'm going to put an import, and that import's going to be on that orders controller. So I'm going to say public orders controller, and I'm going to put an import attribute on it. Once I've done that, in Silverlight, we have this way of making, well, the principle we had in Silverlight is when you need MEF, you should be able to get to it. You shouldn't have to go through any pains. So the way we do that is we have this thing called composition initializer, also not in the desktop. We have a method here called satisfy imports. Why composition initializer is interesting is it works really well for XAML type scenarios. Because MEF really wants to create stuff for you, but there's often times when you're in a situation like when you're in XAML or WPF where the runtime is creating things for you. But you may, like a user control that gets dropped in XAML, the runtime's going to create it for me. But I'd love to use MEF in that user control. And the whole idea of MEF is to make it easy to decouple things. So I don't want all the other code in my application to have to know to call down to this user control to get me the thing that I want. So we introduced this thing called composition initializer. I'm going to do composition initializer.satisfy imports, and I'm going to pass myself in. And when I run this, I should get a message box. Still having faith. There we go. So let's look at what I did there. That was really very simple. I first went over to my order controller. I annotated it with this export attribute. And that export attribute said, hey, MEF, here's something you should care about. I could have specified a contract. I didn't. I used the default, which would be the concrete type. Then in my main page, called satisfy imports. When I called satisfy imports, I already had an import of orders controller there. Now, what did MEF do when I called satisfy imports? The first time I called that, it actually went into the Zap for my application and looked for all of the MEF stuff, anything that was annotated with those exports or those imports. See, this is that zero configuration model. I didn't have to specify in some type of file. Because the problem you get with those central files also is if you've got an entry there and suddenly the component's gone, then things explode because it's looking for something that it can't find. Whereas in MEF, the principle is if it's there, it's there. If it's not, it's not. The system just continues to function. Let me show you this export factory thing, and then we can move on. Okay, so in the example here, I've got this orders controller. Great. Let's go add an order view. Which we will make a user control. Yep. And then in my order view, I'm going to drop an export because MEF is going to be the guy who's the person who's going to discover this, or not a person. Well, maybe I could think about MEF as like a person. Once it loads, we'll do our handy message box trick. Great. Is that working? Yes, it is. Okay. Now what I want to do is I want my controller to be able to create multiple instances because it's going to have a method that's going to get called like create. And every time create gets called, it's going to want to create a new instance. And we'll see in a second how that order view, which right now just doesn't have any dependencies, can pull in other things that it depends on, like an iLogger or an order view model. So to get this export factory thing to work, all I do is I'm going to put a property here called export factory of order view. And now I'm going to add an import on it. Okay. So now let's add a method here, like create orders or something. Create order view. So I'm going to go to the factory and call that create export method that I told you about, and then I'm going to get the view by accessing that view export that came back and getting its value. Now, why do we return that view export? You might wonder, like, why don't you just give me the instance? And one of the reasons for that is we cared a lot about disposability in MEF. When you're building up these large object graphs, you could have anywhere in the chain something that is disposable. Maybe it's holding on to a database connection or some unmanaged resource, which is possible in Silverlight. So what the export factory does by giving you that export, when you're done with it, it's disposable. You can put a using statement around it, or you can call dispose on it. And when you call dispose, anything in the graph anywhere that implements iDisposable will get disposed. So the way we're going to test all of this is we've got this create order view method on the orders controller. Let's go back to our main page, and after this import finishes, let's call on the controller create order view, and then let's call it again. Simulating if the button was pressed 2 times to create the order. Just verify that this all looks good. Say a little prayer. Okay, prayer is done. Okay, that's the first one. Order view created, order view created. You guys get what that's doing? How that's working? Let me show you that it's a lot more powerful than you think. Let's throw another part in the mix, and I can put them anywhere. And the other thing that you can do with MEF, which I'm not going to show now, but I do advise that you go and download the samples, or on my blog there's a series called Hello MEF that talks about partitioning. Right now, everything is in the single zap. Well, we all know in Silverlight, our zaps are going to continue to grow bigger and bigger and bigger and bigger. MEF actually introduces a catalog called the deployment catalog. And the way it finds stuff is through catalogs. So when I'm calling this composition initializer the first time, there actually is this thing called a catalog behind the scenes that MEF creates. And the catalog is just like a catalog that you would order from. It's like, here's all the things that are available that you can ask me for, and I'll give it to you. What MEF will let you do is divide your applications into multiple zaps that will download on demand, which is really cool if you think about taking these large desktop applications and how do I move 700 screens to be a zap. I can't download that as a single zap because whoever's going to use it will go home or never use that application again. But what I can do is download incrementally as the user is doing different things. And the deployment catalog is an async model for downloading components. And then what MEF will do is when those things show up, they're automatically available. So it's really very nice. But let's get on this disposability thing, because I think it's something that a lot of people don't know about. So let's just create a class called IMDisposable. And we'll implement iDisposable. Yeah, let's just let that exception throw, because that'll show us that it actually worked. Actually, Silverlight exceptions don't always work out well. Let's just do a message box. By the way, I actually do know more than message boxes in Silverlight. I'm just taking the simple path that is less likely to run into issues that illustrates the concept. Okay, so this tells me that it's disposed. And now, just to show you the power of the factory, I'm going to go back to my orders controller, which now gets this export factory of order view. And so I'm going to jump on the order view and make the order view pull in that IMDisposable. And let's put an import on that. Alrighty, so this is going to need one other thing because we want to see the disposability work. So we're going to go back to our orders controller and we'll show created. Let's see what we'll do here. So that's the order controller created. We don't need that anymore. We can hide that. We see that works. So we'll create the view, and then we'll immediately dispose of the view. So we can then see how the view itself is not going to get disposed because it doesn't implement. Actually, it probably does implement iDisposable with Silverlight, but the point will be that it will virally make sure that anywhere along the path, even if there are hops in between where things are not disposable, but somewhere down the chain is something that's disposable, MEF will take care of it. And it should happen right with that. Composition, hold on, no valid exports. Oh, I didn't put an export on it. Yep. Orders controller, yeah. So this is that rejection that I told you about. You just saw it. It looks like my orders controller is the problem. It's not. This is the problem. So this is good that this happened. You just saw MEF in action with doing its stable composition. It said to me, the problem is that the controller is not there. Now, you and I both know it's there because we just saw it work a second ago. But as soon as it took a dependency somewhere along the chain that couldn't be found, which meant we couldn't construct it, we elected to just ignore it. So again, there's positives and negatives, but if you understand how it works, then you can design your system in such a way that it really leverages this, and that's what Visual Studio did. If you don't, you could be pulling your hair out. So that's not perfect. So let's go put an export on there. And this should work now. Created. Oh. Did it not run the dispose? Hold on a second. Why did that not run? That should have run. Oh, I know why it didn't run. Because by default, MEF has creation policy. So what MEF does by default is anytime something gets created, it's held around as a singleton. And if I call for it again, I get the exact same instance. Singletons do not get cleaned up when the dispose of the export gets called because of the fact that it's a singleton and something else in the application may need it. If I change this to use a part creation policy, this is how I specify this, I can say creation policy dot non-shared. That says to MEF that every time this happens, create a new instance for me. Now, when I use export factory, I automatically get that for the thing that got created. So you saw that it created different views, and I had two different message boxes that came up. But it shared this. And that's powerful because sometimes you want to do that. You might have some type of repository instance that talks to some services that you want to share throughout your application. You can do that. Another thing you can do that I bet you might not know is instead of specifying the creation policy there, which requires the user to know about it, what you can do is, right here, we actually have the ability to specify a required creation policy. So on the importer side, I can also say, I prefer that I get a non-shared instance, and that alleviates the person who's doing the export from having to put that attribute. It also, though, takes away the control they have because you've now said the only way I'm going to pull something in is if it's using that correct creation policy. So let's try it now, and I think it should work. If not, then maybe I didn't really work on the MEF team. You can talk with Katrine about that. Come on, work. Yes! Disposed. So that, I'm just going to show one more quick thing, which is the metadata, because the metadata aspects of MEF are really awesome, and you're not going to appreciate what I meant by the guideline of use custom metadata attributes if you don't see metadata. So I'm just going to do it very quickly here. So MEF is really optimized to not pull in one thing. It's optimized to import collections of things. I've got multiple foos that are out there of different types, different iFoos, and the application, that's the extensibility point. I can drop 1, I can drop 10. The application just adapts and will process 10 of them or show 10 of them or show one of them. And where the metadata becomes interesting is I can self-describe more than the contract, more than the fact that it's an IFU, additional type of information, like a description, it could be an enum, it can be whatever you want it to be. The common thing that people use metadata for are the things that in the pre-MEF world, which I will call the legacy world, yes, that's arrogant, but I can do that. In the pre-MEF world, which I would say is not the ideal world, you would create custom attributes often that customers would drop an attribute and put a bunch of parameters in. Well, in MEF, you get to do that same experience, only now it has special meaning to MEF, and you don't have to write all that reflection code, but you can still get access to the information. So let's see that one in action. So we'll just go create another part here. And this one, well, we called it foo. Let's just do that. So first let's use an interface. So we're going to create an interface called ifoo. And then we're going to create foo A and foo B. And I'm going to put exports on both of those. But this time what I'm going to do is foo A is going to implement ifoo. By the way, after 3 years of working on the framework, I learned that it's all about foo and bar. The number of discussions we have that are grounded in foo and bar is ridiculous. It's a foo, and then the foo is going to deal with the bar, and then there's the baz. Like, yeah, sure. That makes a lot of sense in the whiteboards of our brains. So I'm going to put an export here and an export here. And now I'm going to say on my user control that in addition to taking what it takes in now, it's going to take in an IEnumerable of foo, ifoo. And those will be foos. Now, because I'm taking in multiple, I'm going to use what's called an import many. Import many says I'm expecting 0 or more. You could put just import. What happens, do you think, if you just put an import attribute? Anybody have a guess? What's that? No. First it encounters was the comment. That makes sense, but not that. Next. Say it again. It will not throw an exception. Well, what will happen is we will look at the collection as the contract. When we do import many, we're basically saying that the T of the collection, that's the thing we're looking for. We're looking for multiple of those. When you do just import, you're saying, that's what I want. Somebody's providing me an entire collection. Look for something that exports the entire collection as opposed to individual things. That's primarily the difference. So is it one collection of things or is it many things that are getting pulled in? And that's why we chose those semantics of import many. And just to give you a little bit of a history lesson, in the past we didn't do that. When MEF first shipped, we would automatically assume when we saw a collection that it was a many. But what happened was it had weird effects to it because somebody would create a class expecting it to be a single import, and inadvertently they might decide to make it a collection. Well, the app broke at that point because MEF suddenly stopped looking for a single thing and started looking for many things, even though that was not the intent of the user. So even though it was very convenient for us to automatically do that, we realized that it's not an ideal situation if somebody just happens to add a new interface. Maybe I inherit from something. Maybe it's not even my fault. I'm a third party that derives from some other component that suddenly decides to implement IEnumerable, and now it becomes a collection. Not ideal. So that's why we force you to be explicit with import and import many. Okay, so I'm going to get my foos. You know, we started down this path, so I don't see any reason to stop. But why is it not? Oh, because it's, yeah. Doing better than I normally do. I would have just gone and done that. Okay, so foo A. Foo B. Let's see what happens. Oh, it's not going to work. I already know it's not going to work. The reason it's not going to work is because I didn't export the right contract. I've exported foo A and foo B. The importer is expecting to get iFoo. This will happen to you, so keep track of this stuff that, I'm the guy who worked on the team. I'm also running on extremely low amount of sleep at this point, so I'll ask for some forgiveness there, but it's good that it's happening because this might happen to you. And be very careful when you're exporting something. Think about the contract. So I'm going to specify here type of iFoo. And I'm going to specify here type of iFoo. And now they should both get discovered if everything is hooked up correctly, and it looks like it is. You're just going to have to keep up with the message boxes. You probably never thought message boxes could be so complicated to follow. Foo A, foo B, and the rest of our stuff that we expected to happen. Pretty easy? Last thing is going to be the metadata. So, right now, I'm causing all foos to get created. I can't distinguish between the foos until the instances are there. Well, what if I have thousands of foos? It's possible. Business rules in a rules engine. But I want to find only a subset. So MEF allows you to do that. The first thing it allows you to do is to say, I don't want to get an actual foo. I want to get a delayed instance of a foo. We call it lazy. If you're familiar with the task parallel library, there was a new type introduced in .NET 4 called lazy of T. We took that a little bit further and introduced a concept called metadata and a special lazy that lets you get access to the metadata. So I'm going to show you what that means very quickly. So here I've got foo A, foo B. But I don't have any real descriptive information. I'm going to comment out these message boxes because we won't need them. Actually, no, I'll leave them because we can see lazy. This will show that it's actually lazy. I have a blog post where I say, sometimes lazy is a good thing. This is one of those times. So the way we do metadata, the default way that you do metadata, and we have a better experience for this. This is not the way that customers have been doing it. So I'm going to add something called name. And I'm going to say that name is foo A. And then I'm going to go on to foo B and do the same thing, only call it foo B. So I've now declared this extra information. The way I access that in MEF is first I create an interface. Now the beautiful thing is the pieces that are providing the export metadata, they don't have to implement that interface. So I'm going to go here and create an interface, which I will call iFooView. And the convention here is I have to put public properties that are just getters, and I use the key that I specified in the metadata, which is name, as the name of the property. So I'm going to say string name, and it must only have a getter, and it can't have public. So that's iFooView. Now I'm going to change this to a lazy of iFoo, and we see we have this lazy T of metadata. So I'm going to use iFooView. Sounds almost like it's profane, but iFooView. All right, so we've now got our order view, we've got our foos. we need to now go back to our orders controller, which is creating the views, which is here. And then we're going to say, for each var, we'll say foo export in view dot, let's see, where is it? What's the property? Hold on a second. Let me go back. Foos. Foos. There we go. Now, I'm going to access the metadata for a reason. First off, what we do here is, I now have, on that export, that foo export, I can now access the metadata and get IntelliSense based on that interface that I provided. But you notice I didn't have to provide a concrete class. MEF will dynamically emit at runtime a class that implements that interface, and it will pull that metadata out for me. So I get a nice compile time experience. So let's run this. We can put a breakpoint. And what I want you to see is that I'm not actually creating anything as far as those. You'll notice that that other message box that I have will not fire. So here I'm in my orders controller. I'm looping through those exports, but you notice that those exports, the instances were not created, because if they were created, I would have seen those other message boxes. So I'm able to access that name information, but I haven't even created the parts yet. That's the power of metadata. Then if I can do a link query against the collection that I got, find the ones that I want, and then just access the value to get those created. So that's allowing me to really delay my resources, but it's more than that. It's allowing me to look at, amongst this large open pool, find the needle in the haystack that makes sense for my application and its state. And the very last part of this that I'm going to show you is, this is kind of ugly. So when I say use metadata, I really don't encourage this style. What I encourage, or what we encourage, is the fact that you can make your own attributes, your own export attributes that are strongly typed. So I'm going to create a foo export attribute here, and it's going to inherit export attribute. And when I do that in the constructor, I have to call the base constructor and tell it, what contract am I going to be? In this case, I'm an ifoo. You notice up top there that I'm specifying ifoo. You'll see in a second I won't have to do that. Type of ifoo. Now, I want this to also allow you to supply metadata. So I'm going to put on top here, this is a little bit hideous, it's a metadata attribute. And this is one thing you have to do. So if you run into problems with creating these attributes, make sure that you do this. So we'll say it's X. It's valid on a class. And we'll say, this is the thing you have to be careful of. You want to say allow multiple equals false. Allow multiple equals false. Yes. If you don't do that, you will be in a lot of trouble. Now this guy is also a metadata attribute, so that means I could do something like this. And once I do that, I can get rid of this guy and just use my new foo export attribute and say name equals foo a. and say name equals foo-b. Don't have to touch the other code because it's completely decoupled. They're two separate things. If I run this, as long as I haven't done anything completely wrong, it might need to be a getter only. It might still blow. Let's see. Did it work? Foo A. Foo B. So this is what I mean by creating custom attributes, because what I'm doing here is I'm allowing, I called them export, but I didn't have to call them export. I'm taking control of MEF. I'm using my own domain language within my application. I ship that in an SDK. That means the user doesn't have to really know about MEF to use that, but it still is an export, so they have full access to imports and all those other things. Somebody had a question. So the question was, can you provide a default creation policy? The answer is no. And the reason for that is creation policy relates to the part. Exports can relate to the part, you can have multiple exports on a single part because we support properties and fields and other things. So the challenge there was, what if one specified a creation policy of shared and another specified a creation policy of non-shared? Which one would win? So that's why we avoided that. We thought about having a specialized attribute that would be explicit and say, if you use this, it really is like something, we allow you to actually annotate interfaces. We have there's another thing people don't know. We actually have an attribute called inherited export. This is a real gem, so I'm going to show it to you. How much time do we have till Katrine? 5 minutes? Oh my God. Okay. I'm going to move on then, because I'm not going to do fairness to all these open source projects that I said I was going to talk about. All right. I'm going to skip this. There's a lot of projects that are using MEF. I mentioned that. What I want to do now is talk a bit about some different projects that are using MEF, and we can jump quickly into some code and see how they're using it. One of the frameworks or products that's using MEF is RavenDB. Anybody here heard of RavenDB? RavenDB is a NoSQL database. And so Oren Aini, or Ayendi, and I always get a kick out of this because he wrote an article, a post a while ago about how MEF was just way too overcomplicated for his needs, and he could write it in 2 hours. And I said to him, well, and Ayendi's an animal, so I said, yeah, you could write it in 2 hours, but you won't have something that an open ecosystem will be using. That'll be something very specific for you and for your thing that you're building. And that may be fine. I'm not saying that's wrong, but that's not really what the goals of MEF are. The goals of MEF are to create this open ecosystem. Well, sure enough, he got a bunch of contributors on this project, and they were like, why aren't we using MEF? They're using MEF. That made me very happy the day that I saw that they actually used MEF. But I made Ayendi happy by telling him about this inherited export. So what inherited export is a way to put exports on an interface so that the implementer of that interface automatically exports that contract. So you saw me doing it with attributes, but this is invisible. This is, hey, you just use my interface. The fact that it uses MEF is irrelevant to you. And what Ayendi uses this for in Raven, or in Aini, as more properly called, is his database allows you to plug in triggers, custom triggers. You can plug in custom queries, and those are code. And he uses MEF to do it. He also has a modularity mechanism that it can extend Raven with all types of different things, like sharding gets introduced as a module. He built it with a modular architecture. And he uses MEF for all of that. So that meant for him that he could focus as much as he wanted to write his code for 2 hours. He got 2 hours back. I mean, I bet he was really happy about that. No. So let's take a look at what that looks like. And I'm just going to search for inherited export within the project so you can see it. Okay, so let's go to Notepad+. There we go. And let's close that. Let's do a search, find in files. And we will go to RavenDB. The search that we're going to do is for inherited export. It's got a lot of files. He's got a lot of files. I might have to hone it in. Doesn't look like it's going to finish in time. Oh boy. Okay. Let's just wait another minute and see if it comes. Come on. It's probably because I didn't specify CS files. I specified everything. Okay. Oh. Oh, well, there you go. So all these inherited exports, let's look. He's got a, so it actually was finding them. I guess I just stopped it. So as an example, I mentioned the idea of how he's got triggers. Where is it? No, it's open. It's just, there it is. Okay. Okay, so here I have this abstract delete trigger, and it's got an inherited export on it. That means that anybody who implements that trigger, all they've got to do is just write an assembly, reference that interface, put it in the right place, they're done. Very convenient. He also uses it for a bunch of things, though. Look, tasks. If you want to extend his system and add your own startup tasks, and think about what you used to do like with SQL Server, right? You had to write all this SQL and do packaging and all that other stuff. This is really nice. You just write a task, drop it in the right place, implement the interface, you're done. And you can look at all this list here. You can see it's quite rich. I mean, he's got document codecs for how to represent different documents. He's got update triggers, read triggers, put triggers. And he's also got, somewhere in here, a query. You can see even updating the schema. All of this is done using MEF. And the thing is, you only see a bunch of exports here. I think there's like 10 of them, or 12. But that could, oh, well, there's a little bit more than that, 18. But that could represent thousands of components in the system that will implement those interfaces. So that's really flexible. So this is one pattern of usage of MEF. This is a pattern of where I don't want my customer to know it's there. I really want to keep it out of their face. And it's also a pattern that says if I have an existing application, like Andy had his 2-hour implementation of MEF, and he had his contracts that he worked with, and suddenly there was like mutiny on the bounty because all the contributors were just like, what's wrong with you, man? You gotta just use MEF. You'll love it. He could introduce inherited export on those interfaces without affecting any of the consumer code. So that's the pattern I want you to think about here that we're talking about, is if you've got existing code that you want to MEFicize, you can do that with inherited export. Or it could be just new code, but you just don't want your customer to have to worry about it. We have an example of this in our own products, LightSwitch. LightSwitch is one of the heaviest consumers of MEF. And what I mean by that is almost everything in LightSwitch, if you didn't know this, is a MEF part. Almost every single screen, every single component. But when you use LightSwitch, you don't have to know about MEF. You can still write classes and other things, and it just seems to magically work. Well, they use inherited export. You can use it on interfaces. You can use it on base classes. Why I like Raven as an example is it's not that UI widget example. It is truly composing the functionality of a system or a framework, A runtime. It's composing a runtime is really what Raven is doing. And MEF plays a nice role there. So that's one. Another pattern is a more explicit pattern where you still don't necessarily have to know about MEF, and this is the custom export pattern. But I am requiring you to do something because the contract is not enough. In Oren's case, the contract was enough, meaning all he had to know was you were an I trigger. But he didn't care about things like prioritization of this one has to run before that one. Or it may be that the model is that the contract itself expresses that information, and I'm just going to create them all anyway, so I'll just look at the individual instances and order them before I call them. So the I trigger has a priority on it. Metadata is when you don't want to do that. You don't want to force it into the contract. You don't even want necessarily the user to have to think about it, so you just put that into the attribute. But another really cool product that Scott Hanselman's been showing off is Glimpse. How many of you guys saw Glimpse and thought that was pretty awesome? So Glimpse is kind of like Firebug for the server. The demo that Scott showed, which I don't have running here, so you'll just have to describe it, but you're running an ASP.NET application, you install Glimpse, you suddenly get this whole dashboard that gives you a deep introspection into what's going on the server, which controllers, which routes. It's incredible. And it uses a mechanism to allow you to put in plugins that look for different types of things, as well as that report to different destinations. And it uses MEF to do that. Now, in this model, what they chose to do was use more of that, the inherited export. Not the inherited export, the custom export attribute. And you'll see how it looks. I know that foo was really sexy, but this actually looks better. I'm almost done. I know we're running out of time, but we're the last session, so if you let me, I'll abuse you a little bit. Okay. So what we want to do is go to Find in Files, and we're going to change from RavenDB to Glimpse. Now with this one, what we're actually going to look for is export attribute, because they've got their own, I know that they've got their own inherited exports. And they should be smaller than Raven. But I should still do that star.cs. What did not like there? Oh, yeah. It's not going to show export attribute. It's going to be inheriting export attribute. So I put the bracket. One thing that's cool, by the way, is because we have these attributes, you can do stuff like I'm doing now easily in an editor. I would do this all the time. When a customer would come to me and say, I can't figure out what's going on with my system, I know, well, let me look for export, let me look for import, searching through the source, and I can find stuff very quickly. It's harder to do that when it's convention. You have to search for every different convention that's out there, and it's much more difficult. So I'm going to try this again. Let's look at some of the custom attributes they have here so you can get a flavor of what they're doing. So this is a Glimpse converter attribute. Now, in this case, I would say this is an anti-pattern. And the reason it's an anti-pattern, sorry, Glimpse guys, they put the metadata attribute, but they don't have any metadata. It's not bad. It's just that metadata attribute is only necessary if you have metadata. And because they put metadata, they needed that attribute usage. But if they weren't, if they didn't have any metadata, and here I can see that they don't, there's no property there for metadata, I actually don't need that metadata attribute or that attribute usage. So only put those if you want to have metadata there. But they're illustrating an important point here, which is even though they don't have metadata, they want to give friendly, discoverable attributes that represent the concepts in the system. So if I want to write a Glimpse converter, I don't have to know do export type of blah. I just drop Glimpse converter attribute. It shows up very clearly in IntelliSense. It's a nice pattern. I endorse this message. This one, however, actually does have metadata. So they're passing session required and should set up in init. So when I write a glimpse plugin attribute, I get to specify some additional information. I know my foo example is so much better, but what you can see here is the real value. Like if I was building my own extensibility framework, I probably would have done something similar, only in my code now I would have been reflecting types and all this other stuff and looking for these attributes, whereas here they just get a very nice experience upstream for working with that metadata, and for you it doesn't look any different. Okay, so I think you get the idea of what these custom export attributes can do for you. I'm going to take 2 more minutes of your time and then we're going to be done. And feel free to not wait if you don't want to. ILSpy. ILSpy is an open source reflector type tool. Reflector used to be open source. Actually, I think there have been some recent announcements that it's coming back. And just so happens that JetBrains is releasing one. And they just happened to announce that they were releasing theirs right before that heartfelt letter came about the change in strategy for Reflector. Makes you go, But ILSpy is an open source version, and ILSpy, like Reflector, has add-ins, and it uses MEF for that. Now, ILSpy is doing a lot more widgets and other things. It's not just non-UI stuff. It's a lot of, hey, I want to write a plugin for viewing this or viewing that. I'm not going to dive into it, but the one I want to dive into, and these guys really devoted their time, and dive in is being used in a what I can show in 2 minutes sense, is this contact center that the Prairie guys, the Prairie Fire guys built using MEF. And they got an award for this. And what this does is, have you guys heard of Office Link? It's our new communication mechanism that replaces live meeting and all those other technologies that should have been killed a long time ago. Can we cut that? So, I'm confident that people in Corp will not watch this video. I always get myself in trouble at least once at a conference. That was it. Okay. So the contact center is really cool, and it won this award. And they have this Ignite client app and this Link provisioner service. Ignite sits next to Link and integrates with it and does a bunch of really cool stuff. So this is Ignite, if you look at the screen here. So there's my Link on the right. Simon, he's the guy who actually created this presentation for us, so he rocks that he threw this in. And there's Ignite. Now, they're using MEF for extensibility, and they're using MEF also for just better maintainability through like view models. There's a lot of customers that use MEF for MVVM that aren't even interested in extensibility. I got a secret for you. It's okay to do that. What I want you to understand is the design goals we had in mind. That doesn't mean you can't use it for things that weren't our primary focus. And we actually did think a lot about view model, because once MEF got to Silverlight, we saw a lot of people would want to do that. And so composition initializer was really about making it easier to do view models, because I could just go into my user control, simply take my view model as an import, and MEF would provide it for me. One thing to remember about composition initializer, though, I wouldn't be fair if I didn't tell you this, there is a problem with it. And the problem with it is it holds things alive. When you create something with composition initializer, it will not go away until the application shuts down. That's fine if you're doing it for things that are singletons on the screen. It's actually perfectly fine. It's not a problem. It's a problem if you're creating lots of things. But you already saw the answer to that, export factory. Export factory will not have those problems. So you could have a view that is static that pulls in export factory to create a bunch of things. But if you were really doing it from a patterns perspective correctly, you would pull a view model in. You wouldn't put that in your UI. And the view model would take the export factories. So basically, I showed you bad code, some of the things I showed you, but that was just to show you the simplest way to do it, not necessarily the best way to do it. Anyway, they've built this call center app, and here's all the ways it's using MEF. They've also taken some of the ideas that were in Prism, Because one of the common patterns you're going to have is you've got these different parts that need to communicate with one another, but they don't know about each other. They especially don't know about each other in MEF because they might have come from two completely different places. So there's a bunch of solutions out there. MVVM Lite is one framework that if you guys haven't heard about, you should hear about it, especially if you're building Silverlight or WPF applications. MVVM Lite has a messenger class in it. You can just throw that into MEF. And you don't need to derive from his messenger. You can use what are called property exports. Just read up on them. They're on my blog. You can use a property export to just new up MVVM Lite Messenger and export it as iMessenger or whatever his interface is, and you can just use it. And they were nice enough to share some production code. This is a product, so this is not open source. But they were nice enough to share some code to show how they're using MEF. So here you can see in their base view model, they've put a property import in. You may not know this, but we honor those imports wherever they live in the hierarchy. So you can do this kind of thing, which is nice because it is insulating. Because they've put it in their base view model, the consumer doesn't have to know about it, but it's still there. They're able to wire in that functionality, which I think is pretty cool. And this slide here talks about the fact that I mentioned this idea of if it's present, it's there. If it's not, it's not. So they've built their system based on that. Their system is adapting their application at runtime and saying, what do you have installed? What you have installed is how I will tweak myself to behave. And no touching of any config file. I mean, that is really powerful, I believe. So then they have this provisioner, which is a separate thing. And the provisioner is going to do a bunch of stuff related to Office Communication Server. And they're planning to expand it over time. But the point is, I think they're using MEF in multiple places. Here you can see they also created their own custom attribute. By the way, you don't have to put the word export in the attribute name. A lot of people do. They choose to. Some don't. You know, there's a lot of different opinions on which way is best. We don't care, but use whatever works for you. So they're committed to MEF, and they're going to be using it going forward. But the point I want to say here is, you know, we showed all these open source projects. We showed we showed RavenDB, which is open source, but it's also a paid product. And we showed, you know, the Prairie stuff that works with Office Link. We talked about Visual Studio. So I think MEF is a technology that's for everyone. And regardless of what type of application you're building, whether it's Silverlight or the desktop, you can use it to solve a host of problems. And I would just advise you, you saw we spun up code here on the fly, how it was pretty easy to get going. And there's a bunch of good resources. If you go to mef.codeplex.com, you'll find a bunch of resources to help you get going. There's a wiki and other stuff. I've written an MSDN MEF article, which is pretty comprehensive, and Brian Noyes, I think, has written one as well. So I'd really advise you guys to look into it. MEF 2, just to give you a quick 1-second overview of the road ahead. MEF 2 is really about investments to take MEF to be more like a conventional IOC container. We nailed the extensibility story. We feel really well. And we've got customers that are saying, well, do I have to use two different things? Like, I use MEF for doing my third-party stuff, and I'd like to use MEF for the other stuff, but I really don't feel like I should have to attribute it, as an example. So if you go on CodePlex right now, you can get MEF 2. MEF 2 includes a convention-based registration using a Fluent API. That means that I can mix and match between third-party things that come into my system and things that I own, but I can use MEF to compose both, which I think is pretty cool. Just to drop again MEF contrib, you could have been doing that for the last 18 months with MEF contrib. But there's a difference between what's in the box that Microsoft is supporting for many customers, some it's not, and those that are not. So I would also recommend checking out MEF contrib. The other thing that's coming in the box is open generic support. That was something that a lot of customers wanted, which is, you know, I want to export a repository of T such that anybody who calls for repository of customer or repository of order, MEF will create that on the fly. In the past, you had to actually export each and every individual one. And they're also doing some work to make it easier for using MEF on web servers. because that really wasn't a thing that we optimized for in V1, just to let you know. You can do it, but it requires a bunch of work, like creating containers per request and managing lifetime and things like that. That's going to be in the box in MEF 2. And if you go to MEF Contrib now, you can get something supported by the community that supports open generics, AOP, and convention-based registration. All right, I'm out of time. I went over. Thank you guys very much. Hope it was useful. Great conference.